Hello, welcome to AERI. My name is Rob Hammond, I'm the president. Our mission is to keep your production lines moving. Let me show you how we do that. It all starts by finding your toughest to find parts from all over the world and inspecting them to the highest standards in the industry. The analysis starts the minute the parts hit our dock. In order to assure that our customers are getting quality, authentic components, we go as far as inspecting the shipment's outer packaging. The packaging of the product can give us many clues to the authenticity of the parts, as well as giving us an idea of the level of quality of the supplier. The outside of the bags or boxes have traits that either give us confidence or cause for concern. The manufacturer's spec sheets often describe the type of packaging, description of the logo, and where it's supposed to be printed. Then we compare that to the actual packaging. The logos on this shipment of ST micro parts were obviously faked. Using a barcode scanner, we can tell if the digital information matches the readable text. Some of the counterfeits we have found had completely different part numbers than were read by the barcode scanner. Once opening up the packaging, we look to see if the parts are packaged properly. If they are moisture-sensitive parts, they require desiccant and a humidity indicator card. If the parts are in manufacturer packaging, without those items, that's a red flag. Then we check to make sure the parts are on the right product carrier. If it's on a tape and reel, are the parts oriented in the same way? And is the leader the proper length to work on an SMT line? As we examine the labels, is the exact part number on the label? Do the date and lot codes match? Do they have the same country of origin? As you can see in this picture, the label says the parts were made in Malaysia, and the parts say Indonesia. Not only that, but they misspelled ROHS. We also take pictures of the packaging and labels and save all this data in our system. In this video, we describe step 2 of our 3-step process, external characteristics. Now we begin to examine the individual parts. First, we remove the sample quantity from random locations in the packaging. Then we pull the manufacturer's data sheet and confirm the components are the correct part. We compare it to the customer's purchase order to make sure we have exactly what they ordered, the right manufacturer and quantity. Now it's time to put the parts under the microscope. After years of experience, our QC techs can spot a fake easily. All of our techs can accurately judge whether or not a part has been blacktopped just by looking at the surface under the microscope. A real part has a dull look with sharp peaks from the plastic molding process. If the parts are sanded down, then blacktop, they usually have a more glossy finish and the peaks look more rounded as the paint settles within the original peaks and valleys. If the parts are sandblasted, in order to remove the old markings, there will be telltale signs of the underlying material of the part. Plastic encapsulated parts have silicone embedded in the plastic, which shows up as small glass spheres when the plastic surface has been etched away. Then we verify that the logo and markings match the manufacturer's specs, as well as comparing them to other similar products we've received over the years. We're also looking for inconsistencies in marking placement and quality. Often when an inexperienced counterfeiter uses a second-grade laser marking machine, they'll burn holes in the part. You can see in this image that the part has both laser burn marks and the logo's missing important elements of the Philips brand. When the counterfeiters try to create a large lot, they have to group together different parts, oftentimes with different variations in the body of the components. The pin 1 placement and other indents need to be consistently placed on all of the parts. In this example, some of the parts were missing pin 1 indicators within the exact same lot. Sometimes the process of refurbishing the part leaves telltale signs of counterfeiting. We've seen flux, chemical residue, dirt, tool marks, and paint where it doesn't belong. These parts were obviously mishandled, leaving micro debris on the surface. Another used sign is cracks or chips on the body of the part caused by the stress of removing it from a circuit board. Looking at the leads under the microscope can tell us a lot as well. Used leads are difficult to get back into perfect condition. It's easy to spot used and refurbished leads because they're often bent, scratched, and if they're retinned, you won't be able to see the copper core at the tip of the leads. Old parts should not have perfectly shiny leads, and new parts shouldn't look tarnished. For BGA packages, we look to see that they're not reballed. Some of the signs of BGAs are scratches that go under the spheres, odd-shaped spheres, or contamination from the soldering process. We are also looking at the condition of the leads to see if they have signs that may make them difficult to mount to the customer's board. Are the leads oxidized, corroded? Do they have socket marks from previous use? Solvents testing. If the parts pass all the visual tests, we confirm that the surface is not remarked or blacktopped through a series of solvents tests. We first take a solution of 3 parts mineral spirits and 1 part isopropyl alcohol to check for marking permanency. This is the test that the manufacturers are required to set their standard to. If the markings are wiped off with this solution, you likely have a fake. Then we try acetone, which is a much stronger solution. If the markings come off with this, that's okay, but there should not be any black paint coming off onto the cotton swab. We also scrape the parts at a very sharp angle with a razor blade. If we see paint flaking off, we know the parts are blacktop. For some of our specialty military and aerospace testing, we can perform the Dynasolv 750 and 1-methyl-2-pyrrolidinone heated chemical test. But the other tests have almost certainly detected whether or not the parts are fake at this point. Once all of the conditions of the parts pass, we confirm the size of the part and the pin count based on the manufacturer's specifications. In this video, we describe step 3 of our 3-step process, external characteristics. The next few tests require some highly technical equipment. We are authenticating the composition of the parts and the internal characteristics. Using an XRF device to check for authenticity has become standard practice. X-ray fluorescence became a very important tool to determine whether or not parts meet RoHS requirements. Most product manufacturers cannot use RoHS prohibited materials in their products anymore due to government restrictions. To use XRF for counterfeit detection, we compare the materials specified in the datasheet to the leads on the parts we're inspecting. If the material composition doesn't match the datasheet, it's very likely the parts are fake. Then we open up the parts to see what's inside. Decapsulation oftentimes gives us the strongest assurance of authenticity. Confirming that the die is correct gives us great confidence. Unfortunately, this isn't necessarily easy. The silicon die is not always clearly marked with the manufacturer and part number. The markings on the die are so small, I like to say that finding the part information, even with the microscope, is similar to trying to find a Coke can on a busy football field from far above. It's not uncommon that the manufacturers use other brands' die due to partnerships or consolidations. We have similar problems with part numbers on die. It's very rare that the entire part number is listed on the die. Usually it's just the part number family. And even more difficult is when it's marked with a die mask number, which is totally unrelatable to the actual part number. That is why we have to look at the die topography as well. After opening thousands of different parts, we have quite a library to compare parts to. There are also telltale signs of different part types that you can see just by looking at the die layout. We also look at copyright dates. If a part was obsoleted in 2005 and the die was copyrighted in 2015, we got some big problems. Once we have the parts opened up, we can get a close look at the wire bonds. If a die has been removed from one part and put into another, there may be 2 wire bonds on top of each other, forming a snowman figure. It's been proven that the counterfeiters are harvesting used die, then remanufacturing parts with perfectly new packages. And lastly, X-ray is a great way to get a glimpse of the internal structure of the parts without destroying them. It works very well in conjunction with decapsulation. Once we know that the die in the part is correct, we can confirm the rest of the lot matches the decapsulated part using X-ray. One of the main observations our techs are looking for is the wire layout and bonding. Are all the wires bonding to the same locations? Are the bonds similar in size? Are they all attached? It is also important to confirm that the die is the correct size and consistent throughout the lot. The attention to detail throughout our process, along with the comprehensive review of the parts, are what differentiate AERI. We go through this painstaking process to keep your production lines moving while assuring your customers that your products can be trusted. To learn more about our additional steps in our inspection process, or to speak with someone about your electronic component needs, call one of our search experts or visit our website at aeri.com.